All right. We'll just go through the solubility curve worksheet, pulling about 12 questions, but I want us to really understand what the graph is telling us, so we'll talk about the graph for just a second before we start. So the way that this graph is made is they take some substance, set the water at a certain temperature, and add the substance until no more will dissolve. Okay? And when no more will dissolve, that's called saturated. So how much they were able to add is what they plot on the graph. So for example, they would start at 0 degrees Celsius and take the potassium chlorate, and they would put it in water, and they only got about 3 grams in there before it stopped dissolving. Now you know it stops dissolving because you see some fall to the bottom. So if it's dissolving, then it's going into the water. If it's not dissolving, then it's falling to the bottom of the water. So if you put over the amount what this graph shows, then it's going to be super saturated, and you should start to see some fall to the bottom. As long as you're under what the graph shows, then it should dissolve. Anything over will not dissolve. Okay? So what the graph asks us first is to look at these amounts that are given and tell if those will dissolve in the water. If it will be unsaturated, meaning more could be added, saturated, meaning that's exactly how much could be added, or super saturated, meaning it's beyond the point at which it saturates. Okay? So the first one says 60 grams of potassium chlorate at 70 degrees Celsius. Chloride. So we just go to 70 degrees Celsius, go up to potassium chloride. How much can dissolve in water at that temperature? About 50 grams. Okay, but we're trying to dissolve 60, so this would be super. Yes. One thing that this graph and I think this worksheet and this video did not make very clear is the only way you can get a super saturated solution is to take the temperature up and get it to dissolve, and then slowly take the temperature back down after you've already got it dissolved. So for example, when you're making sweet tea, like you may have seen someone order unsweet tea and then try to add sugar to it at the restaurant. Well, if the ice is in there, that sugar is going to fall to the bottom. But if that water was warm, the sugar would dissolve, and then once it cools down, the sugar will stay in there. Tea is a super saturated solution. Okay? So the only way to get super saturated, the only way to get this 60 in there would be to go up in temperature and then drop the temperature back down. Yes?
What if it's like below room temperature, like with the ice? Would it be below saturated?
It depends completely on how much you put in there.
So
what example are you using? What are you thinking about, the tea stuff?
Yeah.
Okay. So at room temperature, the tea would dissolve more sugar. Then when you drop the temperature, it's going to be super saturated.
So I'm saying, like, tea can only take 10 grams of sugar.
At what temperature?
At like 50.
Okay.
And say it's at 30. And it takes only like
6 or 7.
Yeah.
It can only take less. Yeah. So solubility is temperature dependent, and you'll notice most of them increase with temperature, but this one drops with temperature. The cerium sulfate. Okay. But most time, if you want something to dissolve more, take the temperature up. All right, 10 grams of potassium chlorate, this time KClO3, at 60. So at 60, how much potassium chlorate should dissolve? At 60 degrees Celsius, about 23 potassium chlorate will dissolve in water. That would be saturated. We're trying to dissolve only 10, so this is unsaturated.
Oh. How do you read this?
Have a latecomer. Okay. So on the chart, where the line is, that tells you what would be saturated. So if you're above the line, you're super. If you're on the line, you're saturated. And if you're below the line, you are unsaturated. Well, there's a different line for each chemical, right? So this is sodium nitrate's line. And this is sodium chloride's line. Some of them are more curved and some of them are more slanted.
Okay.
So for example, let's look at 3. Am I saying right? Sodium nitrate at 10. So we would go to 10 degrees Celsius and find sodium nitrate. Very soluble, okay, right here. So how much should dissolve? 80. We're trying to dissolve 80, so it would be exactly saturated. If you try to do above 80, it would fall out of solution. So you would see some at the bottom of the container. What did we learn in our solubility rules about group 1 compounds? Our solubility rules purple sheet? Group 1, column 1.
Yeah, very reactive one.
Yeah, but solubility rules. Remember we talked about things that will break apart in water and things that stay together in water? So we said that group 1 is always soluble. It always breaks apart in water. But you're seeing here that the group 1s have high numbers, but they're not always completely soluble. Like for example, if you tried to get above 80 grams in water, it wouldn't dissolve. Okay, so those are generalizations. When we said those are always soluble, we're saying to a degree. You can't just keep adding those in water forever and expect them to keep dissolving. Notice on the y-axis, how much water are we talking about here?
100 grams of water.
100 grams. So we're saying that you can put 80 grams of sodium nitrate in 100 grams of water if you're at this temperature. If you had 200 grams of water, how much sodium nitrate could you put in? 160. Okay, so it just follows the trend there, but they have to specify the amount of water they used in their experiment. It's usually 100 on these curves. All right, back to 4, we're looking at calcium chloride at 20 degrees Celsius. So 20 degrees up to calcium chloride. It's approximately 70, and we're trying to dissolve 70, so our solution will be saturated. That means that all of that 70 should dissolve, but if we put 70.2, we're going to start to see some fall out of the solution and be a solid in the bottom of the container. Okay. Any questions there? Yes, sir? Do we do okay so far? What's weird about it?
This is something that lasts could be.
Okay.
I get it now. That's talking to earlier. But then the summer, I was like, I don't care. I got mad at it.
Okay.
I can't read it.
Go ahead, Carl. Oh, okay. Yeah. I think it's going to be right at that. Okay, to 20. I see what you're saying though. You could see 20 as being right here. So then that's above 70, so then you can say unsaturated. Okay, so either of those are acceptable. Saturated or unsaturated. It's definitely not super saturated. And definitely not over the line. All right?
So
Reading? Go ahead.
Oh, so you said it could be unsaturated?
Yeah, on 4, I think it could be unsaturated depending on where you're seeing the 20, because it is blurry right there as where 20 would be.
Okay, because that's what I had, and I was like, oh.
Okay. Yeah, that's good. All right, let's scroll down to 5. We're still reading the graph. Okay, so I might have to scroll up and down. They want to know, at this temperature, how much should be added to form a saturated solution? Well, the graph tells us exactly what's saturated. So all you're doing here is reading straight from the graph. So lead nitrate at 10 degrees Celsius. So we go to 10 and find lead nitrate.
45.
Okay, around 45 grams. Make sure you have a unit there. So we can dissolve 45 grams. Right? The cerium sulfate is the one that solubility decreases with temperature. So we're looking at 50 cerium sulfate.
2.
Yeah, I would say anything less than 5 would be an acceptable answer. Okay, so 2, 3. All right, now sodium chloride is pretty soluble, table salt. And we're looking at 20 degrees Celsius, which is close to room temperature. So at 20 degrees Celsius, okay, somewhere around that's perfect. Around 35 grams of that sodium chloride should dissolve. right, and then potassium chromate at 50. So as we increase the temperature, we should be becoming more soluble. Potassium chromate at 50. Oh, yeah, right there. Okay. 30 grams. Notice most of these lines are sloping, and so they're going to get exponentially larger as the temperature goes up. Like you see potassium nitrate here, it's going off the graph at like 60 degrees Celsius. So very, very high solubility there. And that's kind of interesting because that's saying that you can put more than 100 grams of potassium nitrate in 100 grams of water. So your potassium nitrate would actually become more like your solvent because you would have more of it than water. All right, 9 and 10, underline the solution that's more concentrated. Now, more concentrated just means that it has a greater amount of solute. Okay, more concentrated. So a saturated solution of potassium nitrate or a saturated solution of calcium chloride, both at the same temperature, okay, at 10 degrees Celsius. So potassium nitrate at 10 degrees Celsius, how much solute would it have in the water? Potassium nitrate at 10. This is the curve right here. Potassium nitrate at 10. That's 20 grams. Okay, I'm just going to mark that on here. 20 grams of that. Or the calcium chloride at 10 degrees Celsius. About 63. So which one's more saturated, 20 grams or 63 grams? Okay, so just underline, it says, the one that's more concentrated. All right, now we're looking at 50 degrees. A saturated solution of potassium nitrate, so 50 degrees. Potassium nitrate is almost off the chart, I think. Not 50. 90. Okay. All right, now look at this though. A saturated solution of potassium nitrate, 90 grams, or an unsaturated solution of sodium nitrate. Now, unsaturated just means below the line. Okay, so it could be anywhere below the line, so they have to tell us how much. An unsaturated solution of sodium nitrate consisting of 90 grams of the solute. So again, we have 90 grams. Okay. Let's go back and check this potassium nitrate at 50 degrees Celsius. 50. Is that the right line right there? Okay. So that's 90 as well, right? So which one's more saturated? 90 or 90?
Yeah.
Huh?
DNA.
Yes? 90 grams or 90 grams?
90 grams.
90 grams it is. The 90 gram one is more saturated. Which one is that?
DNA. What?
William?
Oh.
Potassium nitrate is more concentrated than 90 grams of sodium nitrate.
Are you trying to say that they're both
say both?
saturated?
Yeah,
Can we
they're
say
both equally, not equally saturated, equally concentrated. Okay, so these would be equal. So let's clarify that again. We're looking not for which one's more saturated because we see on the chart that the potassium nitrate is saturated and the sodium nitrate is unsaturated. Okay, but this is saying more concentrated. So this one was 90 on the chart, and they told us this one was 90. Those are equal, okay, in their saturation, in their concentration. Excuse me. Say it again.
How you know that concentration?
Okay. This one was saturated, so I looked on the graph, and I saw that 90 grams were dissolved at 50 degrees Celsius. Okay. This one is unsaturated, which just means somewhere below the line. But then later in the sentence, they tell me that it also consists of 90 grams.
Oh.
Okay, in the sentence. So I got 90 grams from the chart for the potassium, I got 90 grams for the sodium. 90 grams, 90 grams, we have equal concentration.
Oh, okay, there we go.
Okay? So it's kind of a trick question. You read one from the chart, one from the sentence, and they turned out to be equal. Right, good on 10? All right, 11. If 115 grams of potassium nitrate are added to 100 grams of water, that's a lot. 115 grams of potassium nitrate into 100 grams of water, how many grams do not dissolve? So you have to figure out how many do dissolve, okay, on the chart. So 35 degrees Celsius, we can see how much do dissolve. 35, and we're looking at potassium nitrate. 35 potassium nitrate, so 55 will dissolve. And the question is, how much does not dissolve? So we had 115 grams that we're adding, minus the ones that dissolved. How much did we say was going to dissolve? 55 grams dissolved, so how many are left undissolved? 60. Good. Now the way that you could easily test this is take and try to put 115 grams in the water and then filter out the undissolved part, and you should get 60 grams that you filter out. The other 50 grams should be in the water, dissolved in the water. If you wanted to test this, you would take the 115 grams and put it in 100 grams of water. Then filter out the undissolved part. We said 60 grams do not dissolve, so we should get 60 grams in our filter when we filter it out. All right, and lastly, 12, what mass of potassium chloride would be needed to form a saturated solution if the potassium chloride was dissolved in 200 grams of water at 80? So we're going to look at potassium chloride at 80. All right, 51, 2, 3. Okay. Now, would that be the answer?
No.
Why not?
Because you gotta multiply by 2, then you got twice as much grams, right? Water divided by 2.
53 or whatever we said was the amount that would go into 100 grams of water. Right? But we want to put it in 200 grams. So there's two ways to do this. You can say 100 times what is 200? 2. So we need to multiply this by 2 because we have twice as much water. Or you could set up a ratio. This much will go into 100. How much will go into 200? Okay? Cross multiply. 100x equals 53 times 200 is 106.
Yeah.
Yep. Okay. Then how do we solve for x? So x equals 106, which is 53 times 2. Okay. But any time that we can see and use a ratio, okay, is useful because we'll be using those a lot. So 106 grams of, what was our solute? Will dissolve in 200 grams of our solvent, which was water. What's that called when you dissolve stuff in water? What kind of solution is that? Aqueous. Very good. What's it called when you dissolve in alcohol?
Tincture.
All right. So that's the end of the solubility curves worksheet. Any more questions?
Can we make rock candy?
Say it again.
Can we make rock candy?